Hi guys, welcome back. So let's take a look at recursive functions. Recursive function is a function that calls itself in order to solve a problem. It is a function that still calls itself inside the function. So what does that mean? For those of us who might be having difficulty to understand what it is to call itself. So let's assume we want to write a function, maybe a bubble sort function. Then you have def, then bubble sort. So this is a function, okay? Then you write your code, your code, your code, your code, your code. When you are done, outside of the function, you call the function, right? When you want to use the function, then you say bubble sort. So you have called the function out of the function. So this is what we have all been used to. But for the recursive function, it's such that you declare if you're writing a function bubble sort. Now, when you write your function bubble sort, you wrote your code, then you call bubble sort again in that code, in the function itself. So calling a function in the function, that function is called recursive function. I hope you understand that. Okay, good. So a recursive function is a function that calls itself in order to solve a problem. So recursive functions solve a problem by breaking it down into smaller instances of the problem. So like breaking down the problem into smaller instances until it reaches a base case. That base case will tell the function where to stop the recursion so that it doesn't go like that to eternity. Now, an alternative approach to using a recursive function is the iterative function. The iterative function. So I will explain a concept or an example with iterative function and also use a recursive function. Then I will write the code for both so that we can understand how both works and we can understand that both will give the same results. So let's take an example. We want to write a function to add up the elements of a list. Let's assume we have a list of numbers, okay? So let's assume we have a list of number LST as an array of, let's say, 1, 5, 7, 9, okay? To use an iterative function, we need to write a for loop, which is an iterative function. You know, for a for loop, we need to specify where the for loop will end. Do you understand? By determining the length of this array. So the length of this array is 1, 2, 3, 4 is 4, isn't it? So we'll now write a for loop to end at 4 because the for loop will go from 0 to 4. It depends, maybe 1 to 5 or 0 to 4 as the case may be, depending on how we want to write our code. Okay, so we specify the beginning. So if I say for I in range 1, comma, length of array, what will this do? This will start from 1 and the length of array is 1, 2, 3, 4. It means it goes from 1 to 4. So it starts from index 1, it starts from I equals to 1, I equals to 2, I equals to 3, and I equals to 4. Do you understand? Then I declare another variable called maybe sum is equal to 0. Then I say sum is equal to sum plus the list of I. Do you understand? So what would this do? Let's draw a table to illustrate this, okay? So a trace table. So so I goes from, it starts from what? From 1, isn't it? So when I is 1, so sum was initially 0, right? So when I is 1, we need the list of 1 before sum, isn't it? So initially sum was 0. Okay, so let me do it this way. Let me write this column as list of I. Okay, so list of I. So when I is 1, because we said range of 1, isn't it? So when I is 1, list of 1 is what? Is 1. No, no, that is wrong. List of 1 is 5. So that means I don't need to start from 1 to length of array. I need to go from 0 to length of array. Do you understand? 0 to what? Length of array. So what I just wrote is wrong, because this will go from 1 to 1, 2, 3, 4, 1 to 3. That is what this will go from. Because range, if you find the range of 3, it goes to 2. It doesn't get to 3. So which makes what I wrote in this bracket wrong. So what I should have written is simple. It is the range of, let's say, 0 to length of array. Then this is right. So this goes from 0 to 3, because length of array is 4. When you find the range of 4, it stops at 3. So you can write 0, comma, length of array. This is allowed. You can also just write range of length of array only. Instead of writing 0, comma, this, both are correct. So the range of length of array. Do you understand? So in this case, length of array is 4. So the range of 4 goes from 0 to 3. Do you understand? Now, when I is 0, list of 0 is what? Is 1. 0 means the 0th position. List of 0 means whatever is in the 0 position. Because this is 0 position, like the 0 index, 1 index, 2 index, 3 index. Is that understood? So list of 0 is 1. Then what is sum? According to this addition, sum is sum plus what? List of 0. What was the initial value for sum? The initial value for sum was 0. Then it adds 0 to the list of 0. This is what? 0 plus 1. And what is the result? The result is 1. I hope you understand that. Then the addition goes to I equals to 1. Then it takes 1. Okay? When it takes 1, what is the list of 1? Which is 5. What was the initial value? The previous value of result is what? Was 1. Then it add what is now sum? List of sum plus list of 1, which is now what? 1 plus 5. And the result is what? 6. Then it now goes for I to be equal to 2. I started from 0, 1, 2. When I is 2, what is the list of 2? 7. Okay, the list of 2 is 7. So what is sum? Sum is the previous sum plus list of 2. What is the previous sum? 6. And what is the list of 2? 7. So what is the result? 13. I hope you guys understand. Now it goes to I equals to 3. So what is the list of 3? 9. Is that understood? So sum is, what was the previous sum? The previous sum was what? 13. And the list of 3 is what? 9. And this gives me 13 plus 9 is what? Is 22. Do you understand? So will it get to the list? Will it get to I equals to 4? It will not get to I equals to 4, because the length of array is 4 and the range of 4 is from 0 to 3. It means it goes 4 times, which is now complete. So our final answer for sum is now equal to 22. I hope you understand that. So to write this function, we go to our Visual Studio Code and write that def the sum of lists. Okay, so we pass our array as what? We pass the array as the parameter. Okay, then we declare sum is equal to 0. Okay, so we declare sum to equal to 0. Then we say for I in what? In length, in the range of the length of array. Okay, for I in range of length of array. Then we say sum is equal to sum plus what? Plus array what? I. Is this understood? I hope this is understood. But we missed something. We did not put a condition. What if the array is empty? If the array is empty, Is there anything to be added? I hope you guys understand that. If the array is empty, that means there is nothing to be added in this array. So one thing we need to do is, before we even start adding, we need to check if the array is empty. Do you understand? So to do that now, okay, to do that now, so in order to check if the array is not empty, then we write this, that if not array. Because when the array is empty, that means array is false. Okay, so if not array, then we return something. We return something to prove that array is empty. So let's return 0 because the array is empty. So else, which means if the array is not empty. So we only add up this if the array is not empty. And after adding, we return what? We return the sum. I hope this is understood. We return the sum. So this is the iterative way of adding items in a list. So let's test our code. So let's take an array or a list of value as, let's say 1. Okay, let me use the previous example in my in the previous explanation, 1579. So 1579. Then we call the function, then we say print, okay, sum list, print sum list, then we pass the array, ARR. Okay, so when we run that, we get 22. So is it supposed to be 22? 1 plus 5 is 6, 6 plus 7 is 11. Sorry, 1 plus 5 is 6, 6 plus 7 is 13, 13 plus 9 is 22. So which is the same thing we got in our trace table. So this is how to do an iterative function. So how do you do this same thing as a recursive function? So let's do that now. Okay, let's do that now. So first and foremost, to do it as a recursive function, you must set a base case. A base case. A base case means where it's ending, where the recursive function should end after calling itself. It should end when the list is empty. So we say our base case is supposed to be 0 when we have an empty list. Is that understood? When we have an empty list, that is our base case. So with this, to do our recursive function, then we say sum is equal to 0 if list is what? Is empty. Do you understand? And that sum is equal to, because we have a list of what? 1, 5, 7, 9. So we will pass all these lists to the recursive function. So what we're going to do is we will add the first element plus the rest, the sum of the other elements. The sum of the rest of the element. Just add 1, the first element, you add it to the sum of the list of the remaining elements. I hope you guys understand my English. Add the first element to the sum of the list of the remaining elements. So it still gives us the same thing. So we say sum is the first element, which is what? Which is array 0 plus sum of the list. And sum of the list is like we calling the recursive function. So let me say the first element plus sum of what? Of the remainder, or of the remaining item in the list. So this is our recursive case. So this is our base case. So this is our what? Our recursive case. So how do we write this function? So we are saying sum of the list of the remaining elements, that is the recursive function. It's like you calling the sum. So sum is the function. So you are still calling sum again inside sum. I hope you understand. So that is the recursive, that is what we meant by recursive function. So let's write this code for recursive function, okay? So let me close this and delete all this. So we say def recursive sum. Do you understand? Then you pass in your parameter, which is what? Which is the list. So let me say array, like we did before. I hope you guys understand that. Now, let's set our base. What is our base? If the list is empty, so we say if not array. That means if the list is empty, what do we return? We return 0. Else, I hope you understand. We return 0. Or let me come here and say sum is equal to 0, and we return sum. Okay, and we return sum, or we return 0. Let's leave it as 0. If we need to make it sum, then we know when we run our code. So else we return, now else sum is now equal to what? The fourth element in the what? In the list. So that will be array 0, the first element. Okay, plus what? Plus the sum of the remaining item in the list. So that means we will call again the what? The function. So recursive sum. We call back the function and pass the remaining element as an argument. I hope you understand. We pass the remaining element as an argument, and the remaining element is what? One full column. Is that understood? Oh, sorry. That is array of what? One full column. So that is what we pass. Array of one full column. So we will call back this function. We called it again. After calling it, we pass an argument. The initial argument we passed was array, which was the full what? The full array. Now what are we passing? We've removed the first element and passing the remainder of the array. If we run this now and test it with our code, then I will draw the trace table to explain exactly what is happening. Okay, so after adding everything, then what do? We return sum. Is this understood? We return sum. So let's declare our array as equal to, I think, 1579. 1579, yes. 1579. This is the array. Then we call the function. So the array is 1579. We call the function, then we say print. We call the function recursive sum of the array. Is this understood? Recursive sum of the array. Then when we run our code, our answer is still 22, just like the previous iterative function. So how does this work? Let's try and analyze our code. How did it work? What actually happened? So let's draw the trace table to understand how it worked. Okay. Now, the first thing to write is the call. That is the calling of the function. Then the action it took. Then the result, or let me say the return. Okay, the return. So in the code, what was the first thing we did? We called the function with this array, isn't it? Recursive sum array. So we called this function with this array. So we said recursive sum, let me shorten it as RS, okay, as 1579. That is what we called. When we called that, it came to the function. If not array has an element, so it doesn't return 0, isn't it? So what does it do? What does the action? The action is sum is equal to array 0 plus recursive sum of this, isn't it? So it takes array 0. What is array 0? Which is 1. Okay, plus recursive sum. We call back the function recursive sum of what? Of the remaining elements. And what is the remaining element? 579. 9. Is this understood? 5, 7, 9. What will it return? Nothing. It waits. Because it's continuing to call until it gets to its base case. It is until it is out of the function before it starts giving us results. So nothing will be added. It is just like when you throw a ball from the roof of a building. The ball goes to the base, which is the ground. When the ball hits the ground, what happens to the ball? It bounces up again back to the roof you threw it from. Do you understand? So that is exactly how recursive works. See, it comes back. When it lands, then it makes that impact. So for now, it waits. So now, after now, do you know that what you have done here means you have called the function again, isn't it? At this point, you have called it. So you said r is 0, which is 1, plus recursive sum of what? Of the remaining. Recursive sum of the remaining means you call the function. The function is called. So you have called the function as recursive function of 5, 7, 9. That is recursive sum of 5, 7, 9. So the function is called, but not with the full array. Array 1 has been removed. Sorry, the value in array 0 has been removed. That is, the first value has been removed. So you are calling with the remaining item. Now, what happens? It checks if the array is empty. Now, is array empty? No, it goes to the else. So what is the action? The action is array 0. What is now array 0? 5. I hope you guys understand that. 5 plus recursive sum of the remaining part of the array. So what is the remaining part of the array? Recursive sum of what? Of 7, 9. I hope you guys understand that. So what will be the return? Wait, nothing will be done yet. When you said recursive sum of 7, 9, did you know that you recall the function? So that means you have recalled the function as rs of what? Of 7, 9. Is that understood? When you call the function, is the array empty? No. It counts to the action. What is the action? Take the first element in the array, which is what? 7, plus recursive sum of the remaining part of the array. And what is the remaining part of the array? 9. I hope you understand that. What will it return? Wait, it returns nothing. Then don't forget, you have called what? Recursive sum of 9. So you call recursive sum of 9. When you call recursive sum of 9, what happens? It's what? It takes the first element, right? That is the action, because it checks if the array is empty. The array is not empty. So what happens? It takes the first element in the array, which is what? 9. Then plus recursive sum of what? Of the remainder. What is the remainder? Nothing. I hope you understand. Nothing. So what will it return? Wait, it returns nothing. Now what happens? You have called the recursive sum of what? Of an empty array. So it is called recursive sum of an empty array. I hope you understand that. So when you call recursive sum of an empty array, what happens? It checks if the array is not empty. Is the array not empty? Of course it is empty. What does it return? It returns 0. Then it returns 0. Do you understand? When it returns 0, that means the ball is now at the base. It is now at the base. So it goes from 0, 1, 2, 3, 4, 5. In terms of index, 0, 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4, which is now the base. When it gets to the base, what happens? It bounces up back and starts from the 4. That means that it returns this value backward, back to the previous function. So what happens? It has gotten to the base, it has returned 0, then it's going back up. Okay, then going back up, it calls the recursive sum of what? Of 9. So 9 is the first element. Then it has the first element to the result of the previous recursive sum. The previous recursive sum, the result is what? Is 0, which gives us 9. It goes back up and calls recursive sum of 7, 9. Don't forget the action is add the first value plus recursive sum the result of this recursive sum, isn't it? So what is the first value? 7. What is the recursive sum of the previous function? 9. And this is what? 16. Now it's called recursive sum of what? 5, 7, 9. So what is the action? Take the first value, isn't it? Take the first what? Value. What is the first value? 5 plus the result of the recursive sum of the previous. And what is the result? 16, which is what? 21. So now it now calls the recursive sum of what? 1, 5, 7, 9. So it takes the first value. What is the first value? 1 plus the result of the recursive sum of the previous value, which is what? 21. And our answer is 22. So that was how we got 22 with our recursive sum. So this is the trace table to explain how recursive function works. Don't forget, it is like you throw a ball from the roof. When the ball gets to the base, before it gets to the base, it does nothing. When it gets to the base, then it goes back to where it's coming from by adding or doing the operation or doing the action it was supposed to do while it was coming down. So let us solve another example. So when we solve another example, that should help us understand better. So let's try to use recursive function to solve problems on factorials. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, isn't it? And 0 factorial is what? Is 1. If we want to write this mathematically in terms of variable, then we say n factorial. What is the first value here? N. What is the next value? N minus 1, isn't it? What is the next value? N minus 2. Then we'll continue to multiply until we get to what? 1, isn't it? Because we have 5, we got to 1 quickly. What if it is 1000? We'll continue to multiply. We can also say n factorial is what? Is n times n minus 1 factorial, isn't it? Just like saying 5 factorial is equal to 5 times 4 factorial. Remember that 4 factorial also means what? 4 times 3 times 2 times 1, isn't it? Now we understand the concept of factorial. So how can we solve factorial problem with recursive function? It's very simple. Now let's take a look at this. So we say n factorial is such that, don't forget that 0 factorial is 1, 1 factorial is also 1. So that means n factorial is equal to 1 if n is equal to 0 or n is equal to 1. Is this understood? And n factorial is n multiplied by n minus 1 factorial if n is greater than 1. Is this understood? So these are the two conditions for calculating what? N factorial. So we say n factorial is 1 if n is 0 or 1, and n factorial is what? Is n multiplied by n minus 1 if n is what? Is greater than 1, according to what we understood from this previous illustration. So if you look at this, n factorial is the function, factorial is the function. We're still calling back again factorial. Can you see? So that is recursive, calling the function in the function. So how do we write this function? That means to write this function, we need to set our base. Where is our base? This is our base. This is the base case. Okay, this is the base case. So for this base case, and this is what? This is the recursive base. So this is the base case, and this is the recursive case. Because this will continue to repeat itself. Then we are setting this as the base where it's going to stop. That is to say, stop at 1 or 0. Because when you are calculating for 5 factorial, you say 5 times 4 times 3 times 2 times 1. Where do you stop at? You stop at 1. So our own code, we say stop at 1 or stop at 0 in case 0 factorial is needed to be found. I hope you understand that. So with this, we can write our code. So how will we write that? So let's go back to our Visual Studio Code. So now, writing our code, so we write the function, let's say factorial. the function factorial. So we put the number we want to find the factorial. Okay. Then we say that if number is equal to what? Is equal to 0 or number is equal to 1, which is our base case, isn't it? Then what do we return? We return 1, right? So we return 1. I hope you understand this. So else, that is if number is more than 1. But what if the number is less than 0? So I need to put that into consideration. So let me say L if number is less than 0, because we can't find the factorial of -1 factorial, for example. So the number is less than 0. So we can return -1. Okay. Then we say else. So this else now means if the number is not less than 0 and it is not 0 or 1, that means it is greater than what? 1. So with this, then we say that the we return what do we return? We return n, that is number, multiplied by, if you go back to the plan, it says number multiplied by number minus 1 factorial. That means we will call the function again, isn't it? So number multiplied by what? Let me put this in brackets to avoid confusion. Multiplied by factorial of number minus 1. I hope this is understood. So this is the end of the function. We set our base. So this is what? This is the base case. Base case. This is just to ensure, that the number whose factorial is needed to be found is not less than 1, right? So, and in this point, this is what? This is the recursive case. I hope you understand this. So if you take a look at this now, we try to run this code now. Then we want to print factorial 5. We want to test this code with factorial 5. Then we run it. So factorial 5 is what? It's 120. 5 times 4 times 3 times 2 times 1, which is 120. So let us draw the trace table of how it's work. Let's understand what exactly happened. Okay, so that we don't just say we know how to write, but we don't know what has happened. So let's draw the trace table to understand what exactly happened with our code and why did it run. So we know that 5 factorial is 5 times 4, 20, 20 times 3 is 60, 60 times 2 is what? 120. So 5 factorial is equal to 120. So let's try and see what happened. Let's draw the trace table. So we say call action, then return. Okay, call action return. So what was the call? Factorial 5 was the call, right? Then that is factorial 5. What was the action? It check if the number is 0 or 1. It is not 0 or 1. So it's check if it's less than 0. It is not less than 0. Then it falls in this else condition. So it takes the number multiplied by, what is the number? 5. Then multiply by the factorial of number minus 1, that is calling back the function, multiply by factorial of what? Of 4. Is that understood? 5 minus 1 is 4. So what is the return? Wait, nothing will be returned yet. So it will be a wait. Okay. So don't forget that you have called the factorial of n minus 1. And factorial of n minus 1 is what? Is factorial 4. Okay. is factorial 4. So what is the number now? The number is 4 multiplied by the factorial of what? N minus 1, which is what? Which is 3. What will it return? Wait. You've called factorial of 3. Then factorial of 3, which is what? 3 times the factorial of n minus 1, number minus 1, isn't it? Which is factorial of 2. What will it return? Wait. Now don't forget you've called the factorial of 2, isn't it? Now factorial of 2, which is now that number, which is 2 times what? Factorial of what? 1. What will it return? Wait. Now don't forget you've called what? Factorial of what? 1. Now factorial of 1, which is now what? 1, isn't it? Is it 1? No. Factorial of 1, it comes back and check. So factorial of 1 is so that it needs to return 1. So it returns 1. So 1 will be returned. That is our base. It has gotten to the base. It's like the ball coming from the root, get to the base. What is next thing? It goes back up, right? And does the function. So now that 1 has been returned, so it goes back to call factorial 2, right? And what is factorial 2? Factorial 2 is 2 multiplied by the result of the previous factorial, which is what? 1, isn't it? Which is equal to 2. Then it goes back and call what? Factorial 3, isn't it? And what is factorial 3? The number, which is 3, times the result of the previous factorial, which is what? Which is 2. And this is equal to what? 6. It goes back and call what? Factorial 4. And what is factorial 4? According to the action, it is still what? Number, which is 4, times what? The result of the previous factorial, which is 6, which is now what? 24, right? Then it goes back to the last step and call what? Factorial 5, which is equal to the number, which is 5, times what? The previous what? The result of the previous factorial, which is 24. And 24 times 5 is what? Is 120. I hope this is understood. So that is recursive function. So if you have any question, you can put it in the comments. I will answer your or reply your comments. If there's a need to make another video to answer your question, then I'll do that. Thank you.